Soil types. In the previous session, we talked about what is exactly the soil profile and what are the different layers that are there in the soil. Now, basing on the type of parent rock, what kind of soils are developed on this planet Earth, we are going to talk about that. Broadly, we are going to classify the different types and we are going to talk about the properties. So, let's understand what exactly is the soil. Now we've already talked about that how weathering of the rocks produces small particles of various materials, right? So we've seen that from the rock we get particles which are converted further into the soil. Now these particles which are formed are further they are further refined and soil is formed, but mainly these are of two types. One is sandy or the sand and other is the clay. Now based on that what particle is more in a particular soil, that type of soil is formed. Whether the soil has more of the sand particles, whether it has more of the clay particles, depending on the percentage or the proportion of the sand or the clay particles, the soil type is formed, right? Also, it depends on the parent rock, right? So, the type of soil, when we say the type is depending on the two types, first is the particles that are there, right? And also the parent rock. Right, so parent rock is the rock from which the soil is formed, right? So what exactly is soil? So soil is the mixture of rock particles and humus, and we've already seen humus is what? It is the organic matter that is present in the soil and it is responsible for the fertility of the soil. So what is soil? It is the mixture of rock and humus, right? Then apart from the plants, other living organisms such as bacteria and earthworms are also found in it, and plant roots also survive within the soil, right? We've seen that how soil has played important role, or how it plays an important role for the plant to obtain water, minerals and even air, right? So we know that plant root breathes through the soil, and with the help of this air which is present between the soil particle, it becomes easy for the plant to obtain oxygen, right? Then soil, when we classify it, it is classified on the basis of the proportion of particles of various sizes. What kind of particle is present in the soil, right? And how much of those particles are present, right? Depending on that, we classify the soil. Whether we have more soil, whether the soil particles are small, whether they are big, and how much of the soil small particles are there, how much of the big particles are there, or whether it is a mixture, that completely is responsible for the classification of the soil, right? So when we classify the soil, we classify it into three parts, that is sandy soil, loamy soil and clay soil, right? Now if you look at the texture of all the three, you might be able to understand a little about that. When we talk about the sandy soil, right? So obviously the name suggests it has greater sand particles, but what is exactly the you can say the property of the sand particles? That sandy soil has large proportion of it has the more proportion of big particles, right? So big particles are more in the sandy soil. Then you have the clayey soil. So the clayey soil has finer particles, right? So these have big particles, whereas the clayey soil, the particle, that is the size of the particle, is quite fine. The particles are quite small, right? And when we talk about loamy soil, this is the kind where there is equal mixture of large and fine particles, right? So the proportion of the large and the fine particles are same in the case of loamy soil. So basing on the size of the particles, the soil is classified into these three parts, that is sandy soil, clayey soil and loamy soil. You can see in this particular picture also there is a relative comparison between the three, that what kind of particles do sandy soil have, what does loam look like and what does clay look like. We'll come back to this picture when we'll discuss all the properties related to the sandy soil, the clay soil and the loamy soil, right? First let's talk and start with the sandy soil and discuss about its various properties. So the sandy soil contains greater portion of big particles, right, that we have already seen, and this is why the soil, any soil which contains greater portion of your big particles is called as the sandy soil. Apart from that, what are the other characteristics of the soil? First of all, the major characteristic which defines or rather which classifies this characteristic is the big particle. But the big particles, because they are quite big in size, they are not close together, right? So what happens is that sand particles do not fit close together, right? The particles do not fit close together, right? So because of this, what happens is, because they are not they are not close together, what happens is you will find that this kind of soil has large air spaces, right? So they have large air spaces. Air spaces are basically the spaces between, suppose this is a sand particle and this is the other sand particle. So this space between the particle is called as air. As the name suggests, the space is filled with large amount of air. Now, when you look at this particular picture, you see that there are large air spaces between the sand particles. So definitely the soil is well aerated. But what will be the problem if we think about it in the perspective of growing plants? There are two major things which the root needs. First is the water and minerals, and other is the air. So air spaces definitely provide enough air because the soil is quite aerated, but the problem with water is that water holding capacity is low because it has enough space, so water drains out quickly in the sandy soil, right? So it has large air spaces, that is why the soil is aerated, right? It's quite aerated soil. But because these spaces are these are big, the water retaining capacity is not good, right? So water drains out quickly, right? So in this way we see that the water retaining capacity is low, right? And what is water retaining capacity? It is the capacity of the soil to hold water within the particles or between the particles, right? So because it has large spaces, and that is the reason why water drains out quickly, so we say that the sandy soil has low water retaining capacity. So all in all, if we think about it, the soil is light, it is well aerated, but it is a light soil. Why is it light? Because the water, there is not much moisture in this particular type of soil, and it is dry, right? That's the reason why it's a dry soil, right? So in this way we see that this is the property of the sandy soil. Now we move on and talk about the property of the clay soil. As we've already seen, the clay soil is made up of large proportions of fine particles, right? So the fine particles are quite a lot in the clay soil. So this is the reason why, because these are fine particles, so they are quite close together, right? So this soil is not as well aerated as your sandy soil, right? But the water retaining capacity of the soil is quite large, right? So it has good water retaining capacity. Right, so these are the kind of particles which are there, and because of this the clay is much smaller, so they are closed together, they are packed tightly, hence less space for air. Right, because they are packed tightly, so there is less space of air, but the water retaining capacity is quite high. High water retaining capacity. Right. Now, over here also in this diagram also you are able to see that this kind of soil, you can see that whenever there is this kind of soil, the water, it is all water that is standing in the soil, right? Because it has high water retaining capacity, that means the water does not drain out quickly in this kind of soil. That is the reason why it is able to hold more water when you compare it with the sandy soil. Right, so this is the kind of soil which is the clay soil. Now, moving on to the next type, that is the loamy soil. This is the soil which has the equal amount of large and fine particles, right? So it has both the large and fine particles in the same proportion. But apart from the large and fine particles, it also has a special kind of particle that is called as silt, right? Now, what exactly is silt? Silt is the deposits, is a kind of particle which is the deposit in the river beds. Right? So, this kind of particle is seen in the river beds. So, loamy soil is actually the top soil. It is the best top soil that is for growing the plant. Right, it is the best topsoil for growing plants because it has a proper mixture of both the for both the fine and the large particles. What happens is that this soil is well aerated and it has a good water retention capacity. Right, in the case of sandy soil, the problem was, although the sand was well aerated, although that soil was well aerated, but it was not able to hold water. Right, in the clay soil the problem is that it has although the water retaining capacity is quite high, but the aeration is quite low. Also, a lot of water causes harm to the roots of the plant. But in the loamy soil, because of the presence of silt, right, and also the same amount of fine and large particles, the mixture becomes quite ideal for the growth of the plants. So what is the size of the silt? The size of the silt is between sandy and clay soil. So silt has the particles which are between the size of sandy and the clay soil, which again is a very good example, or it's a very good size because it does not allow high water retention or high water drainage. That is why it becomes quite a good soil for your growing of the plants. Apart from that, this kind of soil has high humus content, and we already know that high humus content is really important for the growth of the plant. The reason is that humus provides nutrition to the plant, right? So this has high humus content and it has the right water holding capacity for the plants, right? It has the absolutely correct water holding capacity. It is not less, neither more, it is absolutely optimum, right? So this is the property of the loamy soil, which is the best topsoil for growing plants. Now, there is a question that Buju has, and he wants to know that what kind of soil should be used for making matkas and surahis. What kind is the best, right? So for this we are going to perform a very simple activity, and it's quite fun activity for you as well. What we are going to do is we are going to collect samples of sandy soil, clay soil, and loamy soil, right? Then what we are going to do is we are going to remove any kind of pebble, any kind of green plants if there is any root. So basically what we are going to do is we are cleaning the soil so that only the particles of the soil is there. There shouldn't be any pebble, there shouldn't be any green plants, part of the plants, there shouldn't be any root material. If there is any kind of animal remain, you should remove that. So all of these are to be removed. Then what you are going to do is, this is the first step. Second step is cleaning, right? Cleaning means, like I said, removing the pebbles and green plants and etc. Then what we are going to do, third part is we are going to add water drop by drop. Do not add a lot of water because we want optimum water. We do not want the water to be a lot because we do not want that soil to be too sticky, right? We want it just right. So add water drop by drop to this soil, and while doing that you are going to knead it, right? While kneading. So you must have seen your mom also kneads the dough. In the same way you are going to knead the soil, right? Please be very careful while adding water because we do not want it very watery. We do not want it dry. We want it to be just right. Then you are going to do this once you have made dough. Then what you are going to do, see, for example, this is what is happening. You are kneading the soil. This is the process of kneading. Then what you are going to do, you are going to make a ball like structure, right? So first take a sample and make a ball like structure. Then you can take the surface of the floor and on that make the cylinder, right? Then like this, first of all make the ball like structure, right? This is the first step, A part. This is the second step. This is the third step. You make the ball. Then this is the fourth step, right? So it goes like this, right? It's quite a little complicated, the diagram, but as of now you can just read the A, B and C part. So you make a ball and then what you do is you make the cylinder and then from the cylinder try and make a ring, right? After doing this activity, if you take, say, sample A is sandy, then you take sample B, then you take sample C, right? And then you see that which soil was the best and which was the easiest for you to make this ring, right? So ultimate goal is to make this kind of ring, right? And then this will be your answer, that which of these soil will be easy for you for making, or which of the soil should be used for making matkas, for making surahis, for making pots and for different kinds of things. And what you will find is, you will find that clay soil would be the best for making these pots and surahis and matkas, right? You do it on your own and find out what kind of soil will be best, right? So in this way, with this activity, we are going to see that what different soils have their own uses, right? And like we've already talked about the different type of soils and their properties. Now let's answer some of the questions related to the